Okay, we're moving into the second part of Unit 2, and in this lesson I'm going to introduce you to a new topic called logarithms. Logarithms are somewhat tricky when you first learn them, but a very useful method for solving for an exponent in an exponential equation. So we've been doing that already in this unit, solving for exponents in equations. So first off, we looked at ones like the first one. So if 2 to the x equals 8, what does x equal? And that one you might even be able to do mentally, because we know that 2 to the exponent 3 is 8, so therefore we know that x is 3. Then we looked at ones like the next example here, where in order to solve for the exponent, we first want to get the base the same on both sides. So for a base of 4 and a base of 8, a common base we could use is 2. So I could write the 4 as 2 squared to the exponent 2x, and I could write the 8 as 2 cubed. And then remember, we simplified. This is power of a power, so that would be 2 to the exponent 4x. And then once you have the base the same on both sides of the equal sign, the next step was to set the exponents equal and solve for x. So in this case, we would divide by 4. So x is equal to 3/4. Now the problem with those methods enters when we have a question like this one. So solve for x if 3 to the exponent x equals 10. The problem being there's no common base for 3 and 10, the way there is for 4 and 8, for example. So this is where logarithms come into play. So first of all, we need to introduce you to the notation for logarithms. So looking here, I've said if a to the exponent y equals x, then y is equal to log x base a. So logarithms give you a way to write the exponent in terms of the other two parts in an exponential equation. So again, I've said here, this means y is the exponent we put on a to get x. So don't forget, as we're going through this, that really a logarithm is just an exponent. Okay, and again, we pronounce this new notation as log x base a. Now I'm going to go through some examples with you to help you get your head around this. So for example, if we were asked to evaluate log 25 base 5, what you should be thinking is, what exponent do we put on 5 to get 25? And of course that answer would be 2. 5 squared is 25. So that tells us that log 25 base 5 equals 2. Now the next one, log 81 base 3. So what exponent do we put on 3 to get 81? If you don't know that, you will have to use your calculator for some of these questions to figure out, okay, 3 times 3, how many times will give me 81? The answer is 4, okay, because 3 to the exponent 4 equals 81. Now the next one, we have a fraction here, which we have to think about for a minute. So again, think to yourself, 5 to what exponent gives me an answer of 1 over 5? Now the only exponent I could put on 5 that would give me 1 over anything would have to be negative. So in this case it would be negative 1. So log 1/5 base 5 is equal to negative 1. Next one, what exponent do I put on 16 to get an answer of 4? Now anytime your answer is smaller than your base, like in this case 16 to what exponent equals 4, which is a smaller number, you should be thinking in terms of your rational exponents. And in particular, the fact that 4 is the square root of 16. Let's change colors here. So think to yourself, 4 is the square root of 16. That means 16 to the 1/2 equals 4. And that's the answer to this question, 1/2. So the exponent I put on 16 to get 4 equals 1/2. Now the next one is certainly trickier because it says, what exponent do I put on 2 to get 16 root 2? So that one is certainly much more difficult to do mentally. So what I would recommend you do first is rewrite 16 root 2 as a power with a base of 2. In other words, 16 can be written as 2 to the exponent 4, and root 2 can be written as 2 to the exponent 1/2. And when I multiply powers of the same base, I add the exponents. So 4 plus 1/2 would be 4.5, or 9/2. So we're saying, in other words, we could rewrite this question as 2 to what exponent equals 2 to the 9/2. And obviously the answer is 9/2. So we could rewrite this as log 2 to the 9/2 base 2. And of course, no matter what that exponent was, the exponent itself is going to be the answer. Because if we're saying, what exponent do we put on 2 to get 2 to the 9/2? Well, obviously it would be 9/2. And that actually leads us to one of the basic properties of logarithms. And that is this one right here on your sheet. So log b to the x base b will always be x. Because if I write that in exponential form, it means b to the x equals b to the x. That is very difficult to see on this side. And that, of course, will be true for all values. There's some other basic properties of logarithms that you should know. The first one says log 1 base b equals 0. This one here. So in exponential form, b to the exponent 0 equals 1. Of course, that will be true for all b values because anything to the exponent 0 equals 1. Similarly here, log b base b equals 1 for all values of b. That makes sense because b to the exponent 1 equals b. And this one here is a little more difficult to make sense of. It says b to the exponent log x base b equals x. Now I'm aware that makes absolutely no sense to you at this point in time. I think the best way to explain that one to you would be to put some numbers in here. So just for argument's sake, let's let x equal 9 and b equal 3, just to give us nice numbers to work with. Okay, but x and b could be anything. That's the point of this property. But if I let them equal those values, then this would equate to, on the left-hand side, 3 to the exponent log 9 base 3. And then I would evaluate the exponent, log 9 base 3. Try that again. Log 9 base 3 is 2, so this would actually be 3 squared, which is 9. And as the property says, whatever that x value is will be the answer. So you've got some other examples here of those properties, just to apply them. So log 3 base 3, we know is 1. Having some pen issues here again today. Okay, and log 1 base 1,000 has to be 0. The exponent I put on 1,000 to get 1 is 0. And in this case here, this comes from your last property, so we know the answer is 16. But again, if that one was confusing, just evaluate this exponent. Log 16 base 4 is 2. So really it's 4 squared, which is 16. But if you remember the property, it just makes life a little bit easier, especially when that particular logarithm can't be easily evaluated, which sometimes happens. Now, I'm aware this is all probably sounding a little bit confusing, okay? So just bear with this. I think what might be good to do next is to just do some practice of going back and forth between logarithmic form and exponential form. And eventually, not in this lesson, but moving forward, I will show you how to apply logarithms to solve equations like the one at the beginning that we ran into difficulty with. Okay, so it says express in logarithmic form. So the first one is 3 squared equals 9. So in logarithmic form, we would write that as log 9 base 3 equals 2, which means the exponent we put on 3 to get 9 is 2. Notice that, remember at the beginning I said a logarithm is an exponent, so that's why you have the exponent on this side. So the logarithm is the exponent. Okay, next one. 2 to the exponent 9 equals 512. So log 512 base 2 equals 9. So the exponent we put on 2 to get 512 is 9. And last one, 4 cubed equals 64. So log 64 base 4 is 3. And so again, the purpose of these examples is just to get you familiar with what this notation actually means. Okay, because these are exponential equations you're familiar with. We know that 4 to the exponent 3 is 64. So I'm just showing you how to write that in logarithmic form so that you understand where all these numbers are coming from when we start to use logarithms to solve exponential equations. Okay, so now let's practice going the other way. So if something is written in exponential form, how could we write that in logarithmic form? So for example, the first one says log 2 base 4 equals 1/2. In exponential form, that means 4, so the base, which is 4, to the 1/2, remember the logarithm is the exponent, so look on the other side of the equal sign for the exponent, equals 2. And we know that is true because 4 to the exponent 1/2 is the square root, and the square root of 4 is 2, so we know that's true. Log 27 base 3 equals 3. In exponential form, that means 3 cubed equals 27, which we also know to be true. And last one, log 64 base 2 equals 6. So 2 to the exponent 6 is 64. It's the same equation expressed in exponential form. Okay. Last thing we're going to talk about today, and then I'm going to let you get to some practice on just evaluating some basic logarithms and converting back and forth as practice, is common logarithms. Okay, so a common logarithm has a base of 10. So if the base is 10, it's generally not written. So in other words, log x base 10 would just be written as log x. So when you see a logarithm such as the ones in this example, if there's no base, you assume that base is 10. Okay? So, and the advantage to base 10 logarithms is that your calculator can be used to evaluate them. So on your calculator, look for the log button. It might be a second function, but it's probably a button of its own. And in order to use that button, the base has to be 10. Okay, so going forward, I'm going to show you how to convert any logarithm to a logarithm base 10 so that you will be able to use your calculator for more of the questions. But for now, just practice using that button. So log 100 should be 2 because we know that one's easy because we know 10 squared is 100. Okay, so log 100 we should be able to evaluate actually without a calculator. But practice for these other ones. So log 0.5 is approximately negative 0.301. And if you type in log 0, you should get an error. Okay, so there's no solution to this equation because if you think about what this means, this would mean what exponent do I put on 10 to get 0 as an answer? And of course we can't do that. There's no exponent you can put on 10 to give you 0 as an answer. And that concludes this lesson.